Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an Associate Professor in the Department of Electrical and Electronics Engineering. In today's class, we are going to discuss the question bank on Z and Y parameters, which is from the module 5. So, in previous class, we have discussed the same question bank from the module 5, and the topic is about two-port networks. Right. So in today's class, we are going to discuss and we are going to continue to discuss on the question bank from the module 5. So the topic here it is today Z and Y parameters. So especially on Y parameters, we can also call it as a admittance parameters, and also we can call it as a short circuit parameters. So why we are calling as a short circuit parameters, that we will discuss by solving the various problems from this module. Right. So here, first let me consider a simple T network to find or to determine the admittance parameters, are also called as a Y parameters for the given circuit shown in the figure. Right. So here, as we know, the Y parameters we usually represented by the Y. So there are four Y parameters. So the four Y parameters, namely, here it is Y11. Y12 and Y21 and Y22. So these are the four Y parameters. So we are going to find these four Y parameters, right? So then how to find these Y parameters? So first, by short circuiting the secondary terminals, okay, and by connecting the current source across the primary terminals, we can find the two Y parameters, okay. So which are referred to the primary side, which is Y11 and Y21. So Y11 and Y21. These two parameters we can find by applying the short circuit at the secondary terminals and by connecting an current source at the primary side. Right. So then here the circuit will become like this. So here we are connecting a current source which is called, let us consider I1 at the primary side, and the secondary side we are applying the short circuit so that the output voltage is equal to 0. So that's why these Y parameters are also called as the short circuit parameters, because by making the short circuit at the input and output terminals, we will find the various Y parameters. Then first we are going to find Y11. So to find Y11 here, because as we know here Y11, which is equal, because this is admittance, so I by V, so I1 by V1. And similarly here, the Y21, which is equal to I2 by V1, right? So of course here we don't know the value of I1 and V1. So either we should find I1 in terms of V1 or V1 in terms of I1. Then only we can find this Y11. So for that here, what we are going to do, let us find I1 here. I1. So as we know, I is equal to the total current, let us consider here I, that is I1, I is equal to V by R, right? So let us consider here the voltage across the primary side is V1. So in the place of V1, V, it is V1 by the resistance, okay. So the total resistance that we need to find here, then the total resistance here it is, these 2 ohms and these 2 ohms are in a parallel, okay. And this parallel combination is in series with the 4 ohms. Then here I am simply writing 4 plus here 2 into 2 by 2 plus 2, right. So then this is equal to here V1 by 4 plus 1, which is equal to V1 by 5, right, V1 by 5. Then here this is I1 is equal to V1 by 5. Then actually we know what is Y11, I1 by V1, fine. Then Y11, which is equal to I1 by V1, right. So actually what is V1 here, it is what is from this I1 is equal to V1 by 5, then V1 is equal to 5 into I1. So then I1 by 5 into I1, then here I1 gets cancelled. Then here Y11, which is equal to 1 by 5 into S susceptance usually, okay. So the admittance, right? So then here y11 which is equal to 1 by 5. So this is y11. This is the way to find the y11. Then now next we need to find y21, right? So for the y21 again the same way. So here let us find I2 in terms of I1 or I2 in terms of V1, right? But here we can find I2 in terms of I1, right? Because here I2 is the current flowing through this 2 ohms resistor, right? So now we need to find this I2 because by applying the current division rule we can find the I2 value in terms of I1. So here I1 is the total current flowing through the circuit. Let us consider. So in this case here I2 which is equal to, okay, anyway, because I2 is in the opposite direction, because actually the I2 supposed to be, because if this is the total current, so this is one current and this is another current, but here I2 is in the opposite direction to the original direction, so that's why here I am just considering minus I2, right? So minus I2 is equal to the total current here I1, okay, I1 into the opposite resistance here 2 by 2 plus 2, right? So which is equal to 1 by 2. So then here it is I1 by 2. I2 is equal to I1 by 2. Then substitute here the I2 value in terms of I1 and as well as the V1 value also in terms of I1. So from this here we know V1 is equal to I1 into, or 5 into I1. V1 is equal to 5 into I1. So from this equation we know this value, right? Then similarly here what is that I2? I2 is equal to minus I1 by 2, right? So this is minus I1 by 2. Then substitute this value and this value in this equation, right? Then you will get here y21 which is equal to minus 1 by 10s. So this is y21. This is the way we can find the y21 value, right? Now let us find the another two y parameters. Okay, so in the previous case we calculated y11 and y21. So in the next case we are going to find y12 and y22. So here it is y12 and y22, right? So here what is y12? First let us find y22. Y22 is equal to I2 by V2 and y12 is equal to I1 by V2, right? So now again we need to find these two parameters. So here also the same way, either we need to find I1 in terms of V2 or V2 in terms of I1, whatever it may be, so that the both parameters can get cancelled, so that we will get the value of y12 and y22. Okay, so similarly in this equation again here this is I2, the same way. Okay, first let us find the I2 value. I2 is equal to, again same way, generally I is equal to V by R. So here V is V2, that we are considering V2 by, here R, again these 4 and 2 are in parallel, and again this combination is in series with the 2 ohms resistor. So 2 plus 4 into 2 by 4 plus 2, right? Then we will get here I2 is equal to 3V2 by 10. This is the value of I2, right? Then here y22 is equal to I2 by V2. Then just send this V2 this side, so that here we will get I2 by V2 which is equal to 3 by 10. So which is equal to here y22. This is how we can find y22 value, right? Then next y12. Okay, the same way again here y12. So first now which value we need to find? I1, right? So let us consider here also this is minus I1, because opposite direction, the same like in the previous case. So minus I1 which is equal to what is the total current here? It is I2 into the opposite resistor here it is 2 by 2 plus 4, right? Then here this minus I2 which is equal to minus I1. So our I1 which is equal to here 2 by 6 or we can make it as 1 by 3. So minus I2 by 3, right? Then here from this equation, what we can know here, I2 is equal to 3 by 10 into V2, right? Because here I1 by V2 that we need. So just substitute this I2 value as a 3 by V2. So here then I1 is equal to here minus 1 by 3 into here I2 is equal to 3 V2 by 10. Then 3 gets cancelled, right? Then what is Y12 here? I1 by V2. So I1 by V2 which is equal to minus 1 by 10. So then I1, you just send V2 this side, I1 by V2 which is equal to minus 1 by 10. So which is Y12. Y12. So this is how for any given T network we can find the Y parameters. So by making the short circuit of the secondary side, then we can find the other two parameters which are Y11 and Y21, right? And by making the primary side as a short circuit, then we can find the another two parameters which are Y11, Y12 and Y22. This is how we can find the Y parameters. Now, if you want to write these Y parameters in the matrix form, because that is I is equal to, because we are finding I1, I2, I3. So I is equal to here Y into V. So that here I is I1 and I2, which is equal to what is the Y11 here? Y11 which is equal to 1 by 5, and Y12 here Y12 is equal to minus 1 by 10, and Y21. So Y21 here we got minus 1 by 10. Okay, and Y22 here, what is the value of Y22? Here it is 3 by 10, which is equal to into V1 and V2. Right. So which means here, if you write these in terms of equation, so here I1 is equal to this 1 by, okay, so this row into column 1 by 5 into V1 minus 1 by 10 into V2, and similarly I2 is equal to minus 1 by 10 into V1 plus 3 by 10 into V2. So these are the two equations. So by solving these two equations, we can find what is that I1 and I2 values, because here the two variables are there, because anyway to find these Y parameters we are making the both ends. Okay, once in the first case we are making the short circuit of the secondary side, in the second case we are making a short circuit of the primary side. So which means here the voltage, because the voltage across the short circuit is equal to 0, so that's why here we are finding currents in terms of the voltage equations. Okay, so in that way we can find the current flowing through the primary side I1 and the current flowing through the secondary terminal which is I2, that we can find by using this procedure. So this is how we can find the admittance parameters or the Y parameters or the short circuit parameters for the given T network, right? Then we will move to the second problem. So here this is pi network, right? So mostly in your final examination, either you may get the T network or the pi network. Of course, there is another possibility also that we will discuss in the next problem. Okay, and sometimes you may get the circuit with the dependent sources also. That also we will see in today's class. So here, find the Y parameters of the two-port network shown in the figure. Then determine the current in a 4 ohms load that is connected to the output port when a 2 ampere source is applied at the input port. So here this particular given problem containing two solutions. Okay, one is we need to find, as usually like in the previous case, we need to find the Y parameters, and after that if we connect these 4 ohms load, okay, at the output port, which means at the secondary side, and just to replay, and the primary side, if you connect 2 ampere source, okay, so then what is the current flowing through that 4 amperes are the 4 ohms load that we need to find, right? So first let us find the Y parameters for the this given pi network. So here also the same way. First we need to, just apply the short circuit at the secondary side. Then what is that? Consider a current source at the primary side. So this is the way. Okay. Then here also in the first case, what are the two parameters that we can find? That is y11 and y21. So y11 and y21. These are the two parameters that we can find by making the secondary or the output side is the short circuit, and by just include the input side as a current source, right? So here also again the same procedure like in the previous case. So first let us find the current I1. Okay. So here I1, which is equal to V by R. Okay. So V is here V1 by R. So here, as you can see here, these 3 ohms resistor is connected in parallel with the short circuit. So the resistor which is connected parallel to the short circuit is 0, right? So that's why we are not considering, because the resistor which is connected in series with the open circuit is 0, and the resistor connected parallel to the short circuit is also negligible. So that's why here the 3 ohms we are neglecting. So which means what are the two resistors we are having? Only 2 and 1. So how these 2 and 1 are connected? In parallel, because anyway if it is going to 0, then this is short circuit. So 2 and 1 are in parallel. So that's why here V1 is V1 by, and these 2 and 1 are parallel. So 2 into 1 by, here 2 plus 1. So which is 1 by 3. So which means here, 2 by 3. So which means here it is 3 by 2 into V1. So here what is Y11? Y11 is equal to I1 by V1, and Y21 is equal to I2 by V1. Right? So here I1 is there. Then if you send this V1 to this side, then I1 by V1, which is equal to 3 by 2. So which is equal to here Y11. So this is how we can find the Y11. The same way like in the previous problem, right? Then now we need to find the Y21. So to find the Y21, now we need to find the current I2, right? The same way, same like in the previous case. So to find the current I2 here, I2 which is equal to the total current here, it is of course again minus I2, because the opposite direction that we are taking the I2 as a. So minus I2 is equal to here I1 into, okay. So what is the opposite resistor? Here it is 1. 1 by 1 plus 2. Then here minus I2 or I2 is equal to minus I1 by 3. Right? So what is I1 actually here? I1 is equal to 3 by 2 into V1. Okay. So here not V2, this is V1. Okay. Then substitute here I1 value as a 3 by 2 into V1. So here minus 1 by 3 into 3 by 2 into V1, which is equal to I2. So 3 gets cancelled. Then here I2 is equal to minus 1 by 2 into V1. Okay. Then I2 by V1, just send this V1 to this side. Then I2 by V1, which is equal to minus 1 by 2. So which is Y21. So this is how we can find the value of Y21. Right? Then in the second case, what are the other Y parameters that we need to find? These are Y12, okay, and Y22, right? So here how to find Y12? Y12 is equal to, here it is I1 by V2, okay, and here I2 by V2, right? Then for that, here we are making the primary side or the input side as a short circuit, and the output side is a open circuit. But anyway, for that open circuit, we are connecting current source across the open circuit to find the current. Then here also again the same procedure, you just repeat. Okay, first let us find I2 value here. So I2 is equal to V2. The voltage across this terminal is V2 that we are considering. Anyway, again here this 1 ohm resistor is in parallel with the short circuit, so we are neglecting. Then here by the total resistance, here it is 2 into 3 by 2 plus 3, right? Then which is equal to, here it is 5 by 6 into V2. Then send this V2 this side. So here I2 by V2, which is equal to 5 by 6. So which is equal to here Y22. Right? So this is the way to find the y22. Then how to find the y12? The same way again, just find here I1 before we calculated I2. So I1, so because here I1 is again opposite direction, so that's why here we are just considering that as a minus I1. So minus I1, which is equal to the total current here, it is I2 now. I2 into, so what is the opposite resistor? Here it is 3. 3 by 2 plus 3. Then here minus I1, which is equal to here 3 by 5 into I2. Right? But what is I2 here? I2 in terms of V2 here it is 5 by 6. Right? So just to substitute in the place of I2 as a 5 by 6 V2. Okay. Because I2 by V2, right? So yeah, we should not make it like this. Okay. Then here similarly minus I1 is equal to 3 by 5 into 5 by 6 into V2, because here I1 by V2 that we need to find, right? Then 5 gets cancelled and 3 and 3 2's. Then here I1 by V2, then V2 just to send this side. So I1 by V2, which is equal to minus 1 by 2, right? So which is equal to here Y12, right? So this is how we can find, right? Then now if you want to write this one into the matrix form, again it's same way, I1 and I2. So here what is Y11? Y11 is equal to 3 by 2 and Y12 is equal to Y12, just now we have calculated, minus 1 by 2, and Y21 is equal to here Y21 minus 1 by 2, minus 1 by 2, and Y22 is equal to just now I have calculated, which is 5 by 6, right? So 5 by 6 into here it is V1 and V2, right? So this is to determine, to find the Y parameters. So this part we have done, but there is a second part in this given problem. Okay. So again, now let me write these these matrix into the equation form. So for that, because according to this condition here, what they ask, just the 4 ohms resistor we should connect across these secondary terminals. Okay, and here we have to connect the 2 amperes current source. The same way here, this is the circuit, the 2 amperes that we have connected. So then let me write the equations here. So here I1 is equal to 3 by 2 into V1 minus 1 by 2 into V2, and similarly here I2 equation here it is minus 1 by 2 into V1 plus 5 by 6 into V2. So let us consider here it is equation number 1 and here it is equation number 2, right? So here as you can see, from this figure, here I1 is equal to 2 amperes because here the 2 ampere source is there, right? Then similarly here V2 is equal to minus 4 into I2, because here V2 means the voltage across these 2 terminals, right? So what is V is equal to I into R. I is here I2. Okay, R is 4, but actually here I2 is in opposite direction, so that's why here minus 4 into I2 that we can get. Then substitute these I1 and V2 values in equation number 1 and 2. Okay, so substitute, first let us substitute these value, okay, in equation number 1, right? Then what is the equation number 1 will become here 2 is equal to, because I1 is equal to 2, 2 is equal to 3 by, what is that, 3 by 2 into V1, okay, and minus 1 by 2 into V2, right? So just multiply this equation, okay, with 4 or with minus 4, okay. So which equation? The second equation multiply with 4, then the second equation will become, because here minus 4 I2, so that's why here we are doing, so minus 4 I2, okay, minus 4 I2, where here it is, minus 4 I2, which is equal to, actually this equation is minus 1 by 2, so here 2 gets cancelled and minus of minus plus, then here it will become 2V1 minus here 20 by 6 into V2. Right. So let me consider here, this is equation number 3. Okay. And by simplifying this equation, you will get finally here it is 0, which is equal to minus 1 by 2 into V1 minus 13 by 12 into V2. Okay. So which is equation number, let us consider 1, 2, 3 and 4. Yeah. Right. Then by solving equation number 3 and 4, okay, actually what we have to find, the current flowing through the 4 ohms resistor, which is I2. Okay, so by solving these two equations, okay, are just write these equations in the matrix form. If you write these equations in the matrix form, so here what is I1 and I2? I1 is equal to 2 here and I2 is equal to 0. Okay, so which is equal to the first equation here, the coefficient is 3 by 2 and here it is minus 1 by 2 and here it is minus 1 by 2 and here it is 13 by 12 into V1 and V2, right? So into V1 and V2. Then by solving these two equations, then we can get the value of here the V2, which is equal to 3 by 2 into V, right? So already we know what is I2 is equal to, where here V2 is equal to minus 4 into I2. So then here V2 is equal to 3 by 2 into 3 by 2 volts. Then substitute here. So 3 by 2, which is equal to minus 4 into I2. Then here I2 is equal to minus 3 by here 4 into 2, 8 ohms. So this is the value of the I2. So this is how we can find the value, okay, of I2. I mean, of course, not normal I2, because before in the original circuit, I2 is just, I mean, for this particular circuit. But here in the second case, here I2 is the current flowing through this 4 ohms resistor. Okay, so that is the difference between the first criteria and the second case, right? So in the second case, the current flowing through the 4 ohms, here it is minus 3 by 8. But this I2 is not in the first case. This is for the second circuit, for this particular circuit, not for this circuit, right? So this thing we have to remember. This is how we can find the current flowing through the load resistance, right? Then now let us go for the another problem, right? So this is also a kind of pi network, but here additionally, compared to the previous problem, here we are having one dependent current source, which is 3I1. So in this case, then how to find the Y parameters? Okay. So here also refer to the network shown in the figure containing a current controlled current source. So for this network, find the Y parameters. Of course, here also the same procedure. Okay. But let me just give you what is the important point that we should remember. So here I will let you know the two methods. One is the conventional method and another one is the shortcut method. How we can find these Y parameters if you are having like this dependent current source, right? So first let me discuss the conventional way. So in the conventional way, what we can do here first, okay, the same way. First we will find Y11 and Y21. So to find Y11 and Y21, anyway the same procedure, we should apply the short circuit across the output terminals and connect a current source across the input terminal, right? So this is the way. Then how the circuit will become, this is the circuit, right? So or in another words, okay, or in simply, okay, just furthermore reduce this circuit into something like this. Why? Because here these 2 ohms again it is connected across the, I mean, parallel with the short circuit. So that's why here it will become 0. Okay. So that's why here I have considered only this short circuit across here. So then this circuit will become like this, right? Then again the same way, first to find I1. Okay. So this I1 is equal to again V1 by here R, 2 plus 2 by 2 into 2 by 2 plus 2. Okay. So here I1 is equal to V1, right? So here what is Y11, which is equal to I1 by V1. So then sum this one. So here I1 by V1, which is equal to 1, which is equal to Y11. So this is the way to find the value of the Y1. Then similarly, Then here to find this y21, okay, so we are just following the different procedure, not like in the same previous procedure. Okay, so here let us here consider this is the terminal A, right? So apply KCL at A, right? So here I3 is there, and another current here it is 3 I1 is there, and another current which is flowing through the 2 ohms is there. So then here I3 plus I2, okay, so because here I3 and I2 are entering currents, and 3 I1 is the leaving current, which is equal to 3 into I1, right? So what is I3 here? Where is I3? I3 is the current flowing through the 2 ohms resistor, okay, so that is V1 by 2, just now we have calculated. So V1 by 2 plus here I2, which is equal to 3 into I1, right? So what is actually 3 into what is that I1 here, because from this case I1 is equal to V1, right? So then here V1 by 2 plus I2, which is equal to 3 into V1, right? So actually why we are making this one, because here Y21 which is equal to I2 by V1. So here I2 is there, V1 is there. So for that reason only we are making it. Here it is. Okay. Then here I2 is equal to 3V1 minus V1 by 2. Right. So if you simplify this, then Y21 which is equal to here I2 by V1, which is equal to 5 by 2. So this is how we can find the Y21. Right. Then of course the Y11 and Y21 now we have calculated. Then we will go for the second case. Okay. In the second case, what are the two parameters that we can find? Okay. So which are, yeah, in the second case, what are the two parameters that we can find in the second case? So here it is, we are making the primary side as the short circuit, and the secondary side we are connecting I2. So here what are the two other parameters that we can find? One is Y22, okay, which is I2 by V2. Then higher again another one is Y12, which is I1 by V2. Okay. So here V1 we are making it as a 0 by making the short circuit of the primary side. So the same way here, first let us find here I2. So then I2, okay, which is equal to where is I2? Yeah, I2 which is equal to, yeah, in this way I2 which is equal to here, let me consider minus V2 by 2. Okay, minus V2 by 2, right? Then here which is equal to here I dash, okay, which is equal to here I dash. So minus I1 which is equal to V2 by 2, that we know already. So then here Y12 which is equal to I1 by V2, which is equal to minus 1 by 2. So this is how we can find the Y12 value. Then similarly, if you want to find the another one, which is Y22, okay, so then again apply KCL at B. If you apply KCL at B, okay, so here I2 is entering, and of course here I1, 3 I1 is leaving, okay. So then here I2 is equal to, here I2 is equal to V2 by 2, okay, V2 by 2. Let us consider here it is V2, okay. So V2 by 2 plus V2 by 2 plus 3 into I1, because all of the leaving currents except I2. Then by simplifying this, we will get finally here Y22 is equal to what is Y22 here, I2 by V2, so which is nothing but here minus 1 by 2. This is how we can find the value of the Y2, right? In another way, how we can find what is this? The shortcut method that I have mentioned. Okay, so how to find these Y parameters? Okay, so let me write here. Suppose let us consider here it is V1, and anyway here it is V2, right? So first apply the nodal analysis with respect to the V1. So for this I1, okay, so I1 is equal to, okay, just apply the KCL at this particular node, okay. So I1 is equal to, this is V1 by 2 with respect to 2 ohms, and another again here it is V1 minus V2 by 2, right? So then if you simplify this, then here it is V1 minus 0.5 into V2, which is equal to I1. This is equation number 1. So how it is looking like this, I1 is equal to, here it is Y11 V1 plus Y12 into V2, right? So if you compare these two equations, then here Y11 is equal to 1, same like previous case that we have calculated, and Y12 is equal to minus 0.5. Very simple. And in the second case, I2 is equal to, okay, I2 is equal to, other living current here it is 3I1 plus again here V2 by 2 is there, okay, plus again V2 minus V1 by 2, V2 minus V1 by 2. So if you simplify this, then here I2 is equal to here 5 by 2 into V1 minus 0.5 into V2. Again if you compare this, I2 is equal to Y21 into V1 plus here Y22 into V2, right? Then here in place of Y21, here it is 5 by 2, okay, and in the place of Y22, here it is minus 0.5. See, this is the very simple method that we can follow to find the Y parameters, okay, shortcut method, and the before that we have discussed is the conventional method. Again, if you want to write into this one into the matrix form, then the same way, I1, I2, which is equal, in the first case here it is 1 and here it is minus 0.5, and in the second case here it is what is that 5 by 2 and here it is again minus 0.5 into V1 and V2. So this is how we can find the Y parameters, right? So let me summarize the things that we have discussed in this today's class. So first thing is Y parameters is also called as a admittance parameters and also called as a short circuit parameters. Why we are calling as a short circuit parameters? Why? Because to find the admittance parameters, so we are considering the two cases. First, if you want to find that Y11 and Y21, then we are making the secondary side as the short circuit, which means by making the V2 as a 0, okay, then we are finding the short circuit parameters which are Y11 and Y21. Then if you want to find the other two parameters which are Y21 and Y22, okay, sorry, Y12 and Y22, then we are making the primary side as a short circuit. So which means here we are making V1 is equal to 0, right? So in that way we can find the short circuit or the admittance parameters. So in today's class we are consider mainly the three different types of circuits. One is the normal T network, very simple network. Then another one is the pi network, okay. And the third case, of course, again the pi network, but with the independent current source, right? So in these, I mean, in like these problems, if you get, so you can apply the same procedure to find the short circuit or the admittance parameters, right? So in the next class, we will discuss the remaining problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.